Hamisi, a geologist and senior policy advisor with the IGF. Jonathan will give a short introduction to the topic, present the results of our previous consultation, and, for a bit of fun, run a short Menti survey as a follow-up to that initial consultation exercise. So Jonathan, over to you.
Yes, thank you very much, Tracy, for this introduction. So as Tracy says, I will be presenting, it's going to be like very basics on what is waste and what is tailings, because maybe some of us are not very familiar with all the technicalities. So just to give sort of the ground knowledge, but I know Professor Jennifer will later on provide a little bit more deeper knowledge and understanding on different kind of tailings. So I'll be very brief. My presentation is a little bit of a shortcut of the technicalities, and then we're going to look at operating costs for project that already runs, remining and there are different kind of wastes. Not all of them are the same. They include, amongst other, so the topsoil, which is the overburden material that's once removed to access the ore deposits when mining. And we also have the waste rock, which usually end up in a big waste rock dumps. And they also are different kind of waste rock dumps, which presents different risks. So whatever that is removed or extracted and transported to a processing plant will produce at the processing plant what is called tailings. And then if it goes further in refining, then you're also going to have slags or slimes or sludge. So 3 or 4 categories here, so the topsoil, overburden, waste rock, and then the tailings or slags. And all these different kind of material are treated differently. So this is the way they present. So this would be a waste rock dump. So those are the rocks that you remove before accessing the deposit and extracting your ore. This usually doesn't even go to the processing. It's only the ore that goes to the processing. This is a weight tailing. So this is what remains after the process of flotation, usually liquid, might be dry depending on process. This is a slag, so this is usually the way it presents, and there we've got a sludge from or anode slim, so which is a further processing after flotation. So the kind of waste one would generate also depend on the ore processing. If one is processing their ore through heap leaching, what you end up having at the end is a coarse residue and then very large pads of material. When you do flotation, I previously showed the tailing dams, so that's usually what you end up having, and then when you do pyrometallurgy, you end up with a slag, and then refining, you have either slim or sludge. So all these different wastes, they represent different remining opportunity, but also different kind of risks. To give an order of magnitude of how much waste is generated in the specific case of copper, for example, today the global output of copper turns around 27 million tons of copper per year, all put together. So if we would have a global output of 20 million tons of copper, that would mean, in average, at a grade of 0.5% copper, 14 million tons, close to 15 million tons, will end up in the waste rock dump. And then only about 4.1 million will be the ore material that is then sent for processing. And out of that, 4.1 million tons will end up in the tailings. So that's the weight material that I showed previously. And only, so out of that 4.188 million, only 20 million is the copper. So this tiny circle here is the copper. So going from this volume of material, this is what we get if we look at the order of magnitude, which basically means most of the material that are extracted either end up as waste rock or as tailings. So there are different challenges that comes with those materials. Many of you probably have heard about acid rock drainage. That's what happens when you have acid generating material in your tailings or in your waste rock dumps. That ends up being acidic water, which has a negative impact on the environment. Or you end up getting a tailings, which also potentially represents, I think we have seen horrible images, for example, of dam breaking and then having all the slurry running down into a valley. So this comes with risk of physical and chemical stability. Now, another kind of challenge that is different from the technicalities is the legal definition of the tailings. Sometimes in legal framework they are defined differently, which means opening the door for the opportunity to re-mining dams in different jurisdictions might encounter different challenges. In some jurisdictions, tailings are classified as hazardous material, and they directly fall under the oversight of environmental departments, not mining, which means there is basically a closed door for opening the opportunity for remining them. In some jurisdictions, the tailings remains into the custody of the company that is extracting the primary ore, which means they might internally look into the opportunities. In some jurisdictions, the tailing, as soon as you have extracted, the tailing falls back into the custody of the government, which means if one would want to do tailing reprocessing, they will have to apply for a permit as a new application. So there are all these different considerations that comes into play. Some legacy tailings, some of you probably knows, those who have been in the copper belts. This is the Big Eel or Grand Terrain de Lubumbashi, and this is Black Mountain in Zambia. The Big Eel in Lubumbashi was produced at the time where cut-off grades were higher for copper, and ore processing was less efficient, which means there is a fair amount of copper that remains in there. At the time, the Jeka mine used 2% as cut-off grade, or we know that today in modern mine, in some large porphyry copper deposits, you can mine up to 0.18%. So having a TRL at 2% means you have a very large amount of copper that you can still recover. So now a quick insight into processing costs or operation costs for tailings. So what we've tried to do with this study, so we are now conducting, I'll say background or literature study of how much it costs to reprocess tailing. And in during the research, we actually realized, so if we look at, this is a figure that shows total cash costs for operating, and then on the x-axis, it is paid copper in thousands of. So if you take Metal Gold, which is a tailing reprocessing project in the DRC that produces copper and that produces copper and cobalt, the total cash cost, that's Metal Gold, is about $1,600 per ton. But the total paid copper, it's at a very low end. If you take Escondida, which is one of the largest mines in the world, the total cash cost, so extraction cost per ton, is at about $3,750. At the higher end, so if you take a mine like Konkola in Zambia, it has a higher processing cost or production cost. It's more on the higher end of $8,000 per ton. So we can see that it varies. And the variation is due to the type of operation, the type of ore, sulfide, oxide, but also energy costs and labor, etc. And that's what these divisions here, the different color here, they represent different kind of costs. So the blue here is labor for Escondida, the orange is energy, and then we've got the green, that's the reagents, so the chemicals that are used. The blue, or the purple here is offsite costs. These are TC/RC, so treatment and refining costs, and then on top we've got the royalties. And you also see that it changes, it varies from one country to another. So if we take some other example from South America, these are big porphyry copper deposits. In Brazil, the Mineiro Valley Central, which is also a tailing reprocessing project, we see that it also falls somewhat at the higher end, with an average of $5,000 per ton for production compared to its peers primary deposits. So here we're looking at the very same category of deposits. All of them are porphyry copper. In the previous charts, we mix different kind of deposits. I might just skip this one. This is an example for lithium. When we look at lithium, the Kamativi deposits in Zimbabwe, when we look at the average cost for other type of deposits, so here, for example, we've got some of the deposit in Australia, Mount Catherine, which is also pegmatized deposit. Its production costs are way higher than the average for pegmatitic type of deposits. And the Kamativi deposit, which is pegmatized type, is more at the lower end. Now, if we look at other kind of deposits, these are the salars deposits, so a different kind of ore deposit. And Kamativi is still this one here. We can see that for most of the salar deposits, so the parts in green, which is the processing plants, that's the higher cost that you have in those operations. And what we can also see is that when it comes to processing costs, the pegmatite type, so which have normally the kind of operation as you would have in ordinary, I would say, kind of deposits, crushing, milling, concentration, they would typically have lower processing costs. This is the change in processing costs. This is a typical example. So after the ban in Zimbabwe on exporting raw material and processed raw material was imposed in 2022 and really entered in force in 2024, we saw a reduction in processing costs, and the biggest jump was on what is called other on-site costs, and also on energy and on labor, which now in Zimbabwe they produce processed ore, most of the time mostly crushing and physical separation, but we see the jump in the production and then the lowering in cost. And this is also the cost for the Kamativi project deposits, which is tailings. Now, after giving this background information, we will run, I think I will skip presenting the survey from last time, but we will run a new survey, and I will invite you all to take out your form. I will put up a QR code. Please scan it. It's a very simple question. It's some yes or no question or sliding questions. What we want to try to achieve with this survey is to try to capture as much as information to feed into our report, and we will want to take advantage of the wealth of knowledge that is into the room. And after this survey, I will give the word back to Tracy to take over the expert presentation. So please scan the code, and we will be running 90 together.
Jonathan, I think you were too quick. The code is gone.
Yeah, it's gonna come. I'll bring it back.
Yeah, please.
I will bring it back. So there you go. And we will progressively go from one question to the other as you respond. So we will also want, it's not going to show anyone's email address, so we're not showing personal details, but please pinch in your email if you would want us to get in touch with you later on, as we will be progressing in the production of our reports. The reports will be basically a guidance document for governments to look into what are the factors, the aspects that are important to enable tailing reprocessing. What are the challenges and risks to evaluate to put together a regulatory framework that is appropriate. That's 60. 16 over 23, so next, then I'll go to the next session. So I've reached the end. We haven't quite reached the end. Sorry. There you go. Yeah. Yes, I think there was an issue. So now I restarted it from the start. So these guys can again QR codes. I apologize for running into a little bit of technical issue in there. I started the survey by the last question, so but now I'm starting it for the first one. I'm gonna try and see if we get to 34. Probably will be happy with 25 already. Give it a few seconds. You can see that South Africa is very much represented. And the idea is also the perspective from different countries and different experts. Okay, I guess we'll dive into the next question. Does legislation exist for the remining of waste in jurisdiction you live or work in? Try and get it maybe to 20 if we can. And 19. That last one bit. Great. Let's go to the next question. What are the main critical metals minerals that could be produced in meaningful quantities from remining waste in your country or where you work? Okay, we got a few answers there. I'll try to get to 20 again. Okay, so we got 20 answers. And I go to next. What are the most important benefits from remining waste? From least to most important. They're a little bit of a quick, short answer and maybe a little bit of a shortcut because we do know the complexity of legal frameworks, but this at least sort of give us a bit of a glimpse of what are the thoughts or the thoughts process around. 18, I'm gonna try to get 20 again. Yeah, so great, so we're gonna go to the next question. Please tell us more about the opportunity you rated the highest. Why is it important? Doesn't have to be a very long answer. This can be just one word. For example, say it's critical minerals, it's important for the energy transition, etc., etc. Can make it a short answer. You can put as many answers as you want for this particular question. Oh, employment and value creation, I like that one. Removing source of acid rock drainage, excellent, that's a good one too. Resource conservation, that's one good too. I can see there are a lot of answers around environmental aspects, which is really good. Good to see. You're gonna try and get also 20 answers on that one. Start at 18. Well, we're gonna go to the next question. What are the biggest challenges with bringing a remining waste project into production? Again, least challenging to most challenging. Just slide the bar, and we should start getting the answers. It's interesting that technology and project finance move at pace. Okay, so we got, oh great, we've got 21 answers, excellent. But yeah, that's a very interesting on technology and project finance. So we're gonna go to the next one. Please tell us more about the challenge you rated the highest and why is it important? Again, a one word, very short answer would be sufficient. Cost of projects, expensive to launch. Regulation, that's a big one. We realized that as we were looking in different regulatory framework for several countries, most of the time it's there's a gap. Okay, so we've got 19, 20 kids. What are the most important policy and regulatory requirements for authorizing the remining of waste materials? Again, from least to most important by sliding the bar.
That's interesting. So again, we've got technology, which almost always most important, and then here we've got, as a close second, requirement for community and stakeholders. That's also interesting. I was expecting C to be one of the highest one, but community and requirements, that demonstrates availability of suitable technology. So we're gonna go to the next question. Any other points you would like the IGF to know about as we develop this policy recommendation? Please also feel free to pinch in. It doesn't have to be a very long answer, also a short answer. So I said at the beginning, your contribution will fit into this policy recommendation or guidance document that will be published by the IGF. Pollution risk, yeah, important one. Consider clear and consistent regulatory framework, it's pretty good. Remining and repurposing of bulk waste is not the same thing. Very good point there. Very good point. Yeah. I guess we will be talking more about it as we go along today. That's a very good point. Because the question is also, is remining really circularity? Do we consider circularity for electronic waste, or can we consider it also for tailings? So very good point, we've got 22. And then I think a few of you had already responded if you would be willing to be contacted in the future. So I think this brings to an end the survey. Thank you very much for your contribution. All the comments that you have put together will be very helpful for us as we work on this guidance document for government. And with this, I will hand it over back to Tracy. But you're not using that.
No, that one's got a volume button for me. So thank you very much. Great. So that was a bit of fun. Thank you very much for the perspectives. We're going to now move to the part of the discussion this afternoon where we've got some really fantastic expert panelists who will be sharing some of their views on aspects of this discussion, of this topic. And the first person I'd like to invite to share some perspectives to open the panel. We'll start with Professor Dieudonne-Louis Tamboue from the, excuse my French pronunciation, the Cellule Technique de Coordination et de Planification Minière, otherwise CTCPM of the DR Congo. Do you have some slides that you're going to share with us? Okay, fantastic. So just by quick way of introduction while Professor gets ready, he is the coordinator of the CTCPM, the DRC government's technical advisory and studies body supporting the National Executive on Mining Sector Policy and its interfaces with other sectors. As a university professor, he holds a PhD in chemistry and process engineering and is widely recognized for his expertise in mine planning and the research and development of extractive processes that support sustainable valorization of mineral resources. So with more than 20 years of experience in teaching and research, he's also played a key role in major sector reforms, such as contributing to the revision of mining contracts for state-owned companies and leading the commission that revised the mining code from 2013 to 2018. So as the coordinator of the CTCPM, he serves as a key focal point for collaboration on activities carried out under the bilateral cooperation framework between the DRC's Ministry of Mines and BGR, implementing a project on the remote sensing inventory and risk assessment of mining waste in the DRC Copperbelt. So this work provides valuable insights into the scale of the waste deposits and the risks they pose. So over to you, Professor Tambwe.
Thank you. Okay, I've been invited to talk about this, mining waste in the DRC Copper Belt. Oh, sorry. I have so many things in my hands. Okay, yeah, I was saying I've been asked to talk about the mining waste in the DRC Copper Belt, a remote sensing inventory and risk assessment as part of the cooperation between Germany and DRC. And yes, as it's written there, we can say, sorry, I think I would need another hand. So I would say, yes, this is part of the bilateral cooperation in between DRC and Germany. Yeah, I think that's better. Yeah, you know, this technology sometimes is putting us at risk. Yeah, so I was saying the study has been conducted under the framework, as you have said, of the bilateral cooperation between Germany through BGR and the DRC. I would say the Ministry of Mines, which is more represented here by the CTCPM, which is the main focal point of the Ministry of Mines. CTCPM, as you have said it, is Cellule Technique de Coordination et de Planification Minière. And since 2009, BGR has been involved, among other activities, in promoting responsible mining and good governance, while since 2024, in the current project phase, which has started from 2024 and is going to last up to 2027, we be concerned more with this economic development and responsible supply chains in the Congolese mining sector. Now, who am I, or who is the, what is the CTCPM actually? Skip, please. Next. Okay. Cellule Technique de Planification et Coordination Minière, CTCPM, is the Ministry of Mines Specialized Service, which, under the supervision of the Minister of Mine of the DRC, has, among other missions, the conceiving and implementing policies and strategies aiming at optimizing the DRC mining sector. The reason why someone has said it, I think in my bio, it has been said that we've been involved in the reviewing of the Mining Act of the DRC and the mining regulations. I just offer you pictures of the two major texts. And we're also in charge of coordination of initiatives that are coming across the sector, the mining sector, as the natural focal point. We also do planning and monitoring mining activities from exploration to mine closure. That is all along the value chain or the life of a mining project, from the access to the resource to the end or closure of the mine. Skip, please. Oh, okay. I hope you noticed also that there are some statistics, so we are also in charge of this, because among our many functions and missions, we have also the mission of providing, gathering data and then broadcast them. And statistics are also part of what we are doing. The reason why you saw those figures of statistics. Now, why does the DRC Copper Belt matter when it's about inventorying of environmental issues regarding dam or tailings? It's because in that region, particular region of Africa, which encompasses DRC, Zambia, and I think part of Namibia, and even we can consider also some parts of Angola. It's because in that particular part of sub-Saharan Africa, we have such a concentration of a mining activity, and this has been for years. Because we've shown there a picture with the big hill of Gécamine. I would just remind you that Gécamine, which was formerly the l'Union Minière, they started the operation at that mine of Kipushi in 1900. And the first production was in 1911. From that time, they were mining Etoile, they were mining Kipushi, and they were constituting, because then the plant, hydro plant, was Usine of Lubumbashi, the UL, which is very, very close to that big hill. So, all around the copper belt part of Congo and part of Zambia, you have a lot of mining activities, all, in the past and in the present, and probably in the foreseen future, we'll still have them there. And it has been said here that when you're mining, you're producing a lot of, I was about to say rubbish, you're producing a lot of tailings. When it's about, you have done your job, extractive metallurgy, then you remain with tailings. Otherwise, when you have just mined before even, yes, when you're just using selectivity, you know that, okay, in this part I will have some minerals, okay, and this is the ore, which is interesting you, that you put aside for the treatment. But the other part is what's in French you call sterile. It means you don't expect very much to have something there. But things are changing, and that terminology of waste is actually, it is not that much used anymore today, because waste is something, okay, we won't use it anymore. But we know that with the new innovation in technology, in science, whatever, there is almost always a way to revisit those dams, those tailings, and probably to beneficiate for something, especially in a world where not only that we have now new technologies. It has been said here that we can go now, we can tackle up to 0.18% for copper. In years for zero USD, they will say, no, there's nothing there. You better bring us something which is above 3%, and this is something which is unacceptable. But when people, they don't know exactly what is metallurgy and what are but that was the situation 56 years ago. That was the situation when we were doing only pyrometallurgy. Today we know with some chemistry doing only pyrometallurgy. Today we know with some chemistry you can go. You can find a way out to go down to. I remember 10 years ago or 15 years ago I was in Morenci in US. Those times we were saying, okay, we can mine up to 0.025% of copper, 0.25. And we were saying, oh, that's too low. And we were discussing, because remember, I was saying here that CTCPM, we are also in charge of statistics, how beneficiation can be done. And you can see that tremendous change of technology. We are saying, no, you cannot do that. But now go back to this big hill. You'll find there amazing tenure. And that's the reason why I know Umicore today is there on But before then, we had this STL, and people were beneficiating of. And now that we are in this era of transition energy, which is so demanding in many minerals, it has been said that in Indaba, Africans are saying, okay, today, every element, every commodity can be just considered as a critical one, because we don't know. We don't know. So, okay, just to say that, okay, we have those tailings, we have those dams that are, and that was actually the part I wanted the most. When I received the subject, I was saying, oh, that's good. We're going to speak metallurgy. But then, okay, let me just remain on the environmental, the subject. What is interesting, okay, I've shown you that in that DRC copper belt area, and also Zambian, we have many operations that are still going on. At least 55 copper mining operators that are generating large volumes of tailing and waste rock. About 134,000 artisanal and small-scale miners. And then what I have to say that artisanal digging, artisan ASM, they're not doing that, they're not producing that huge amount of where the tailing go down, because operations are done mostly in DRC by hand with small, very, very small material, okay? So, but, as it has been shown, to get, when you have a tenure of 2%, 3%, 4%, even 5%, you see that the raw material, the one you have, that those artisanal miners are rejecting is far huge volumes than what they're extracting. So anyhow, there are a lot of, let's call them, just quoting them, waste, and it might be a problem. It might be a risk which exists. If you can go to the next slide, this is the kind of the risk we have been. We have unfortunately in the very recent days. I will talk about the picture which is at the right. That's a sad situation that happened in the Katanga, Lubumbashi, few months already ago, and it was a TSF that had a kind of defect, and we had rivers of acidic effluent down to Lubumbashi. It was in November. Shambishi, which is in Zambia, has also unfortunately offered such a kind of TSF failure, and it was in February. Meaning we are at risk, and that's why it is so important finally to have this kind of study, to know on all those TSF, all those what do we call them again? The acronym. We have a risk which is there. Either you have a tailing storage facility which is there. We need to monitor the stability to know the membranes. How are they in the long term, and whether you have also a waste rock dump, that is the WRD, as somewhere I've seen there. You need to be monitoring those things. And the problem in the DRC, we know what is currently in operation, but we have mostly forgotten what has been operated years ago. And this study is good because we've done the remote sensing method. They could find out those those kind of from what, yeah. And then, okay, oh, this is maybe the most interesting for me, economic opportunity, but I think probably Professor Broadhouse is going to talk more about it. But yeah, I'm very interesting because, as a matter of fact, I worked on these tailings. I used to work on them when I was doing my PhD at Centrale in Paris. And I remember I did a study. I did also the study of there were also tailings in Kolwezi on what was then called Usine à Zinc de Kolwezi, UZK. I did it, and when I finished my PhD, I gave the result of the study to the CEO of Jacquemin. Then they said, "Oh, young man, we're gonna call you back." And unfortunately, a couple of weeks later, they had sold it, and someone else is operating. And I knew there were not less than 20% of zinc, not less than 2% of copper, not less than something in germanium, gallium, because what was treated at the UZK was actually coming from the Kipushi mine. And Kipushi mine is a very beautiful polymetallic ore body. And all of that you can find at the end of the treatment. You can find that either in what you are producing or in what you have considered as a waste or just a tailing. So it was a lost opportunity. This one also I remember, and it was good. And well, it is working. It is working, and it is good. Good, really good. So, okay, I don't want to, yeah. So the general objective of this study was, okay, to conduct a remote sensing inventory and an environmental risk assessment of copper, cobalt mine waste facilities in the DRC, just to be sure that the kind of threat or catastrophe we have seen last year, and probably more before, we are not going to have them every time, because the risk is there since there are so many dams, so many TSF, and anytime they might become a problem for us, which means we need to concentrate, to focus on them and see. Probably the regulation should be enforced, and we are doing also this at the CTCPM. The reason why we are so much interested when BGR is coming is doing those studies. We are monitoring together with them. And yes, potential application of this study is we strengthen government oversight of mine waste facilities, which can be done in terms of regulation, stronger regulation, and also just a geo-referenced inventory and risk screening helps for the authorities so that they can prioritize inspections. We have a direction of environmental protection, which is there. We have also the ACE, which is Agence Congolaise de l'Environnement, but they need this kind of study. They need to know where are the priorities, where the risk can just erupt suddenly, and so that we are not surprised. We know, okay, this is risk 1, this is risk 2. So let's work on the major risk. And if we can do that, we be done. And then we have this reprocessing, and that's my favorite, but we talk about on the next time. Now, we need to know that the database that are known, if you go to the next, I think, yeah, not this. This is methodology. We may come back later on. Okay, this, we are just presenting the TSF and the other. Yes. Now, we have those databases that are saying, okay, the global tailing portal, which is a database, is saying, okay, there are 10 TSF in the DRC. The I code, let me find out. So it stands for what? It stands for I code. International Commission on Large Dams, which is also known as World Register of Dams. They are saying, oh, okay, as far as DRC is concerned, they are seeing only 3 of them. But the study, this remote sensing study, has shown that we have not less than 126, which means from what is known, what is reported by the database, and what this study is about to show, there is enough room to do further research. And this is probably what I can say at this point. Thank you. I see that you are really about to take back your microphone. Take it. Thank you so much.
Thank you, Professor Tambwe. Oh, that's wonderful. Okay, first of all, let me give Jonathan back the clicker. Right, there you go. Thank you very much for that. And actually, some of the questions that I had for you, I think you've already started to cover. So, well, you know, you can never take the professor out of the classroom.
Not a problem with professors. I'm just trying to be the most explanatory possible, so that I know, even if I say, okay, now I'm gone, people will say, okay, you may.
No, that's fantastic contribution.
Say the essential. Sorry about that, Professor.
And
I know.